In episode 13 of Mobycast, Jon and Chris discuss the future of serverless. Welcome to Mobycast, a weekly conversation about containerization, Docker, and modern software deployment. Let's jump right in.
All right, welcome, Chris and Rich. It's time for another Mobycast, and every week I've said the number, but this is like when they after they were done with the iPad 2, they decided to call the new iPad just the iPad. So I've lost track of the number, and from now on, it's just Mobycast. Welcome.
Hey, how's it going, guys?
It's good. So yeah, what have you been up to this week, Chris?
Well, that's a great question, actually. Today has been kind of the unusual week, and that it's just literally been focusing on like one thing, which is the project that I'm kind of leading up. So just doing a lot of driving out ambiguity from various ideas and turn it into features that we can act upon and then go execute against it. So today's been no travel, no fires, no nothing like that. Just a pretty straightforward week, and those seem to be rarer and rarer. So I'm thankful for that.
Excellent. And how about you, Rich?
So this month was actually a record-breaking month for Secret Stash, and actually the month prior was as well. So we had 2 months back-to-back that had real nice growth as a result of this outbound strategy that we've been doing since January. And the other side of that is I actually have been outside more than at my computer. I went and hit some golf balls, and then 2 days ago, and then yesterday went on a hike. And so, in the wake of that, I'm also finding myself with a little bit of more balance than I'm used to. So this week it wasn't very productive, but it was nice to actually maybe enjoy that reward a bit.
Yeah, speaking of outside, this week I got a chance to try out the new Riverwave feature that they built in Eagle, Colorado. Got my surfboard out a couple times and surfed on it, and it's super fun, and I'm so happy that it's just a few blocks away. For the surfer and me, it's like a welcome that I can do that in Colorado. Unfortunately, though, this year we did not get enough snow, so I'm already sad because we've passed peak runoff, and looks like my river surfing is going to be limited to maybe another week or so. But in other news, on the work front, hopefully by the time you hear this, I'm sure of it. By the time you hear this, there's going to be a real class on prodockertraining.com that you can buy, and you can come and you can attend and you can learn. And you won't just have to listen to us talk about this stuff. You can actually be with us in person and work with us directly.
And where is that workshop?
We're going to start doing these in Seattle. We may eventually also do some in Denver. I'm not sure yet. Right on. But absolutely for sure Seattle.
So we'll link you up in the show notes for a direct link to that.
Great. So this week we're going to talk. We talked last week about all the things that happened at GlueCon and sort of the state of the world when it comes to modern software deployment, containerization, and DevOps. And the conversation took longer than 20 minutes, and we didn't get to everything. And one of the things that's just a hot topic is serverless, and we wanted to talk about it and really dig into it some more. And so we thought we'd spend the entire time this week talking about serverless. So I think today what we can try to do is Chris and I can try to talk about serverless, and really, because hopefully it's been clear from our previous conversations that we're maybe not entirely on the same page. We maybe don't totally agree, which makes for a fun conversation. And I want to figure out where the boundaries are. What is serverless good for? What is it not good for? Who should be using it? Who shouldn't be using it? And even if people that aren't using it, that are using it that shouldn't be, so there's all these people that are using it that shouldn't be, what's that going to cause? What's going to happen with serverless if there's this influx of people that shouldn't be using it that are? So to get started, I've said this word serverless a bunch of times, and if you haven't been listening over the weeks, it might be worth just getting a little refresher of what that is. So Chris, can you tell us what serverless is?
Yeah, that's a great place to start, because that was actually the very first thing that came to mind. Is like we first have to kind of have a definition of what serverless means, because I think it's definitely mutated over the years as just things have evolved. So in general, I mean, serverless means that you're running your code on servers that you don't have to manage. right? And that's where the serverless part comes in. So there are still absolutely servers, right? You can't just run bits of code in the ether. They actually have to run on computers, servers. Someone has to manage it. But when we say serverless, usually we mean that someone else has the headache of managing that infrastructure, not you. So they basically are providing computing resources as a service, and your code goes on them. So in the most general sense, that's what serverless means. I think, early on, this really, I think it was around 2013 when AWS came out with Lambda. And that was kind of like the beginning of the buzzword serverless. And so at that point in time, serverless really equaled Lambda. But we're now starting to see the word serverless applied to lots of things, like RDS, Aurora, now has they call it a serverless option. There's ECS now has a serverless option called Fargate. So we're starting to see just this word leak out into any other scenario where you're not managing the servers yourself. Someone else has that headache of how do you provision those and scale them and just monitor, troubleshoot, deal with them, apply updates and whatnot.
Cool. Thanks for that. And I'll also say, it's been my experience that a lot of the people that jump into serverless are ones that maybe came from platforms as a service. Some folks that have done some monolithic Python apps and Rails applications and maybe used Heroku. This is a really attractive looking option because it seems like the next step on a general trajectory. Heroku is platform as a service. All you had to do was just tell Heroku, here's my GitHub repository, go deploy it. And Lambda feels sort of similar. Hey, Lambda, here's my function, go deploy it. And I think one of the core differences, though, is that with Heroku, even though you weren't necessarily managing the servers, you were managing you did have to do a lot of management of the workload that the servers were capable of handling by turning on workers and turning them off. But also, Heroku didn't prevent you from getting in there and sort of seeing what was going on. So with Heroku, you could, for example, with a Rails application, you could still run a Rails console, which is like a live terminal, into your server. So you could poke around, run functions, see what's happening in terms of memory usage and a few other things that with Lambda, it's not the same. So Lambda specifically, and this is not Fargate or Aurora serverless, but with Lambda specifically, you get you call a function and the function executes on servers that you don't have any control over, and you get a return value or a timeout or an error. And that's it. You don't get to log into Lambda and see how it's doing. There's nothing like that whatsoever. And I think that's a real core difference between platform as a service and Lambda specifically in terms of serverless architecture and running applications that maybe catches some people off guard. Before we continue, I wanted to talk about a talk that was at GlueCon by Nate Taggart, who's really excited about serverless, and he's a CEO of a company called Stackery. And he did a talk called Self-Healing Serverless Applications at GlueCon. And the first slide, I've never seen that, like, such a wild reaction in a developer conference where I think every single person in the room put their phone up and took a picture of the slide. It was ridiculous. He was a rock star for a moment. And what he did was he said, well, this is what Lambda advertised itself as in the beginning. When he first learned about Lambda, here was what was on AWS's page about Lambda. It said, AWS Lambda invokes your code only when needed and automatically scales to support the rate of incoming requests without requiring you to configure anything. There is no limit to the number of requests your code can handle. So that sounds like magic. And if somebody can provide that to me, I think we can all just turn off our DevOps teams and just do that. But when he actually started using Lambda, he decided on a few edits, and he did these on the slide. It was edits as though an editor had edited it with a red pen. And he changed the slide to read, AWS Lambda invokes your code sometimes when needed and can scale to support certain rates of incoming requests, but requires you to properly configure everything. There are limits to the number of requests your architecture can handle. And everybody just loved that. And it's true. It's absolutely true. And when you start to use Lambda, I think that's what comes out, is that it's not magic. It's computers doing what they're told.
Hey, this is Rich. You might recognize me as the guy who introduces the show, but is pretty much silent during the meat of the podcast. The truth is, these topics are oftentimes incredibly complex, and I'm just too inexperienced to provide much value. What you might not know is that Jon and Chris created the training product to help developers of all skill sets get caught up to speed on AWS and Docker. If you're like me and feel underwater in these conversations, head on over to prodockertraining.com and get on the mailing list for the inaugural course. Okay, let's dive back in.
So I think where I want to go next with this conversation is, you've heard that. Maybe if you could give us, Chris, your sort of take on when does your mind say, let's do this with serverless. Let's do this. Let's maybe talk more about Lambda, although I am interested in hearing more about Fargate at some point, but let's kind of stick with Lambda for now. When does your mind say Lambda is the solution? Lambda is the right answer for this?
Yeah, I think for me, the one magic word there is event. So when there's some piece of my system that is reacting to an event, then that may very well be a good candidate to say, like, this should be hosted on Lambda. So I think one of the advantages of Lambda is when you need to get something done that it's pretty straightforward and simple, pretty isolated, pretty contained, and the overhead of creating the scaffolding to wrap it in a service kind of feels like overkill and a lot of work for it. And that's kind of, I think, the way I look at Lambda is that it's kind of providing you that kind of like the boilerplate framework foundation, the scaffolding that you need in order to run code in the cloud. So if you've got something that's pretty targeted, and especially if you're leveraging other things in AWS that are emitting events and you want to act on them and do transformations or trigger other things, then Lambda ends up being a pretty high at the top of the list, something to look at.
So in my mind, I have a hard time really knowing what the difference is between, and I want to go right into it. Like, what's the difference between an event and an API request?
For some people, there's not much of a difference, but for me, it is pretty. I do see a delineation. So I would say typically, like when I say event, I'm kind of thinking more along the lines of events that are generated by other services that are part of my architecture. They're things that don't necessarily need real time. They're responses. So think of them as more asynchronous as opposed to synchronous. You absolutely, you can go build an API server composed entirely of Lambda functions that are fronted by API gateway, and you can think of those incoming requests as events. But again, like for me, I'm definitely more of a fan of thinking of this as more of like I need to take actions based upon what's happening in the state of my system with the other components. And so have them emit events, send events that then trigger these things that they don't need to be done synchronously. They can be done asynchronously.
Right. I think we can kind of get to why API requests and using Lambda for those is maybe not the right solution in another way too, which is that Nate's talk was just so good. I'm looking forward to actually catching up with him and talking through some of this in more detail. But one of the things he did was he laid out some of the common types of errors that come out of Lambda. And there were two main types. There's runtime errors and there's scaling errors. And the runtime errors are, he laid out three, but the two that I just want to mention here are uncaught exceptions. So your code, barfs, and Lambda's like, hey, your code barfed. Or timeouts. Timeouts is really significant. So Lambda's maximum timeout is 5 minutes. Anything longer than that, it's absolutely guaranteed to timeout. Anything shorter than that will time out if you haven't manually set the timeout to 5 minutes. In a lot of cases, you'll want to time out for an API, especially you'd want to time out more in the range of like 5 to, seconds to, dozens of seconds at most. So those two types of errors, you have to do stuff about them. And Nate suggested, obviously with uncaught exceptions, you have to manage those no matter what you're doing. So it doesn't matter if you're in Lambda or if you're in ECS or if you're on Heroku, you've got to make your code resilient against uncaught exceptions. But with timeouts, you largely don't have to think about the infrastructure kicking you out when you're running on ECS or Heroku, or platform as a service. So you have to do extra work in order to make your code resilient against timeouts. So that's just a trade-off, right? So you get some of the infrastructure for free, but now all of a sudden you have to. Nate's suggestion, which I thought was brilliant, was to sort of wrap your code in sort of pre-timeout indicators, like, looks like the 5 minutes is coming up. I'm going to have an internal, thing happen in my code that tells me I'm stuck. Here's where I'm stuck. I'm about to time out. So just so you know, this is what's about to happen, and then return, as opposed to letting Lambda shut you down. And I thought that was brilliant, but that's work. I mean, that's there's no way around that being work and complexity that you have to add to your code that you may not have to add to your code if you're running somewhere else. So I thought that was kind of interesting. And then the other types of errors that happen in Lambda are around scaling. Lambda has concurrency limits and spawn limits. Concurrency limits are how many things can run at once. And you can have AWS change those, and you don't necessarily know what they are, but you get errors when they happen. And then spawn limits are how fast you can scale up, how many new Lambda functions you can call in a short period of time and scale quickly. And both of those just, return errors to you. And your code has to be ready for them. And I think if you're building a service that can scale and you're doing it with Docker and you're doing it on ECS, you can just kind of plan in advance for that, and you don't have to be surprised by, we hit this sort of mysterious scaling limit of AWS, and now we have to react to it in a strange way that's very different than just adding horsepower. And sometimes it's, in terms of brain damage, the amount of effort it takes, it's like sometimes it's just easier to add horsepower to an ECS cluster than it is to work around some arbitrary and weird scaling limits that you have to discover on your own inside inside of Lambda. So that was a bit of a long explanation of errors and sort of the difficulty that you have to add into your own code to deal with the Lambda errors. But do you think that's sort of another way of approaching this and making that decision, Chris?
Yeah, I think the big takeaway here is that you still have all the problems of like running production software in a distributed system, regardless of whether or not you're running it on Lambda, someone else is running the servers, or you're running it on, bare metal yourself. You still have to deal with all this stuff. So, what about code that takes a long time to run? Like you have to deal with that same problem, whether you're running in Lambda or whether you're running in ECS. In ECS, your ELBs are going to time you out after 60 seconds. So if your code's taking longer to respond than that, it's going to get cut off by the load balancer. You're still spending resources on the back end. That may not time out, but it's still happening. Of course, if you're running up against these timeouts, like that's when you start kind of like looking at your code and say like, there's probably something wrong here, right? Like if I'm actually putting in code to like a timer to like say like, hey, I know I'm about to be killed, so I'm gonna throw a timeout so that I can go ahead and log something. Like maybe instead of doing that code, you should be looking at like, why is this taking 5 minutes? This is probably not the right way to do it, right? So I think it kind of goes back to just this is no silver bullet. So serverless is no silver bullet. You still have to be at the top of your game. There's a lot of complicated issues at play, and it solves some problems, but it's no silver bullet, and you're still gonna have to deal with these things regardless of where your code's running.
Right. Just to kind of talk about that one thing about the timeout code, about having Lambda tell you, or having your function say, I'm about to timeout, and having it do that instead of Lambda. I just wanted to give a little bit more of the reasoning behind that. When Lambda times out your function, you don't get a stack trace. You get nothing. And if you have, let's say you're scaled up to, 12,000 calls per minute of your Lambda function, even if you've written just the best code, it's going to time out sometimes. There's going to be a database connection or a DNS issue, or something's going to happen that times you out. For sure. It just always happens. And so that's why I thought that solution was a little bit brilliant. But again, it's a solution that you may not have to do if you're sort of managing your own infrastructure and you have your own control over timeouts, as opposed to letting Lambda just shut you down with no information. But good point about the load balancers being able to do that to you too. It's like someone's going to turn you off somewhere and not tell you why.
Absolutely. And in a distributed system, there's multiple actors, and each one of those have their own rules and regulations on that stuff. So it gets pretty complicated pretty quickly.
Right. And then a personal story is recently I was looking at deploying some code, and I was kind of torn between doing it in Lambda and doing it in ECS. And interestingly, because of all the things that we've just talked about how it's really, you don't get everything for free. You don't get logging management. You don't get library management. You don't get deployment. You don't get all that stuff for free with Lambda. You still have to, for example, what I needed to do is I needed a fairly substantial library for my code to be able to run. And it wasn't available just as a drop down, pick this library type of thing in Lambda. So I would have needed to package it up and put it in a zip file and get it over into Lambda. And I was like, well, if I'm going to do all that, why don't I just put this in a Docker container and put it on ECS? And it was sort of like that trade-off was like, it was kind of a no-brainer for me. It was like, I'm going to use ECS because then I'll have more control over things. The argument for Lambda is that the whole thing might have been a little bit cheaper because you only get charged when the function gets run. But we weren't talking about a break the bank amount of money as it was. So running it on ECS was totally affordable as well. And then it gave me more control and more access to what's happening. Well, cool. I think, we've basically talked about this for 20 minutes and the takeaway is use Lambda for events, and sure, go ahead and use it for applications if you want, but don't expect it to do anything magic for you. And I think that's probably what we'll do. We'll continue to use it for events. Do you have any other additional things just on serverless or this conversation that you think will help put a different light on it or add to what we've already said, Chris?
One of the things that comes to mind that kind of continue blown away by the cyclic nature of technology. And it's you can kind of think of like Lambda as almost going back to like mainframes and punch cards. Like, here's my punch card, my Lambda function. I'm going to give it to you. Go run it, and I get back the results, right? Mm-hmm. And saw the same thing with client server. Like this kind of feels like batch computing in a way. So just kind of an interesting way of thinking about it, and just what's old is new, and what's new is old.
Oh, there was something I brought up at the beginning that I wanted to talk about just for another minute. I talked about, well, what is going to happen if sort of the masses that may not be thinking as completely as would be helpful in how distributed systems should work, all pile on and write applications on Lambda and put them into production and try and maintain them. And, there's just this influx of Lambda usage. What do we expect to see?
Growing business for us.
Yeah, that definitely could be part of it. Yeah. I mean, I guess some optimistic part of me hopes that some of this stuff is stuff that you can just do for people, and that there may be a future where it's like, yeah, just think about your business logic. Just worry about your business rules. But I don't think we're anywhere close to that yet.
No, and the ecosystem continues to evolve and to provide support around those areas. So I mean, it's happened with Lambda. I mean, to start off with, it was very bare bones, and now there's frameworks around it as well to kind of really kind of give you a lot of that support, and to make things easier. I think the more that you end up kind of like, it's kind of like the trade-off of going with a highly opinionated solutions versus the more flexible things. So the more opinionated you go with, the more support that you're going to get, right? And the more stuff you're going to get out of the box versus doing it your own. So I think we'll see that same evolution happen in the serverless world.
Great. I think that's a good way to wrap it up. Thank you so much, Chris and Rich. We'll talk to you next week.
All right. Thanks, guys. See ya.
Later.
Bye.
Well, dear listener, you made it to the end. We appreciate your time and invite you to continue the conversation with us online. This episode, along with show notes and other valuable resources, is available at mobycast.fm/13. If you have any questions or additional insights, we encourage you to leave us a comment there. Thank you, and we'll see you again next week.